Hello everyone, my name is Mike Burnhill. I work for Canon Europe. I am the product specialist and technical person responsible for Pro DSLRs for Europe. I've been very involved with the development and feedback of the 1DX, and this morning I'd like to talk you through some of the technologies and background behind it. At the end, hopefully we'll have some time, I can answer some questions, and I'll be around if you want to ask anything else I haven't covered in the presentation. So let's just start off with talking about where the camera came from. Previously, DSLRs, there's always been a compromise. You either had high resolution or high speed. It was very difficult to make a camera that did both. This has been a holy grail going back since the dawn of digital cameras. You couldn't have both. However, now technology has reached a point with our digital processing and our sensor technology that Canon felt we could now make one camera that did everything. So previously we had the 1DS, our full frame range, and the 1D, which is our APS-H, slightly smaller sensor, which was designed for high speed. So back in 2007 we had the 1DS, and in 2009 we launched the 1D Mark IV. So the idea was to make one camera that could do both jobs, and we believe 1DX is the camera that would do that. So let's talk about a few of the technologies involved. I thought I'd start off with the metering system first, which will lead us into other systems. So 1DX features our next generation metering system. It has a 100,000 pixel RGB sensor. So that's almost like a digital sensor from a digital compact built into the camera. I think the amazing thing is it's actually powered by a Digic 4 processor. So the actual processor you get in your 5D or a DSC just looks after the metering for the 1DX. It looks after looking for faces, it looks for colors, which helps us produce new technologies such as the intelligent tracking and recognition and the intelligent scene analysis systems. These are two technologies that will run in the background of the 1DX. So the ITR system basically is the metering system and the AF system working together. So the camera will detect a face and then help track the subject based on where the face is. So it's actually face detection technology that you may see in DSC cameras where it picks up a face and follows it around. But because it has the power of a Digic 4 behind it, it runs in real time, very fast. So it's going to be ideal for sports, and obviously the colour system as well. We pick up on colours. There's no faces, it would defer to a colour. So we're looking at the moment trying it out on wildlife, etc. Because it can detect faces and detect colours, the performance and flash exposure is sort of much more reliable. The face has a similar reflectivity no matter what skin tone it is. So we can actually, once you know there's a face in the scene and where the face is, you can use it as a grey card. You can use it as an 18% reference. So I can look at a subject and say, there's a person here, so that's where I can take a good reference of what the exposure is. Again, greens are always traditionally very good for taking exposure values from, because it has a very similar activity. But other colours, yellows are notoriously difficult to get right if you don't know what it's a yellow. So in old metering systems, yellows tend to be sort of underexposed because the amount of light it bounces back to old metering systems. Now you know it's yellow, it's much easier to get the correct exposure. Also, because we have a face in the scene and the camera knows what the face is, flash exposure will be much more improved for people photography. Because again, you can reference where the person is and where it should concentrate its flash exposure. So it's going to be ideal for red carpet events or just general weddings, because we now have a built-in light source reference point, which was missing before. Weddings are traditionally difficult. You have a woman in a white dress, a man in a dark suit. Where should the camera take the flash reading from? Now you have faces, and this is basically the camera can ignore the rest and concentrate on those points. So this brings us into the autofocus system. So now we can track on colour and basically faces, which is all fed into the AF system. So obviously the headline specs you may have seen before, we now have 61 AF points. We have much more cross types than ever before. We have cross types with f4 and 5.6. Traditionally, we only had cross type AF points with 2.8 lenses. So now we have 61 cross points for 5.6 lenses, 21 cross type horizontal, 5 dual cross type for 2.8 lenses in the center, and 20 kind of peripheral points. So as we look here in this view image, in the center we have the red area, which is our kind of all our main cross types are there. But we also have 2 bands of cross type either side for up to f4 lenses and 2.8 lenses, and obviously 5.6 is really the red ones in the center. The blue ones are extra high precision dual cross type in the very, very center. People often say, what's the benefit? What is this cross type we keep harking on about? Why are they so important? What's the big fuss? So if we take these 2 objects here, often sometimes an AF point may not always, an AF point needs contrast. Without contrast, AF system doesn't work. You can pick up any camera in this sort of hall and point it at a white object. It will struggle to focus, or a black object, because there's no contrast. It needs detail to be able to focus, just as you would with an old manual focus camera. You need to be able to see some difference. So if you have a vertical AF point, you can see here on a horizontal line, no problem at all. You have white and blue, very easy, lots of contrast. But on this vertical line, no contrast, it's just blue. The AF system can't focus. If we go the opposite way, basically you can see the same issue is going to happen. By having a cross type, we're now covering ourselves on both bases. Wherever there's an object, there's twice as much chance of picking up contrast. So it's much more accurate and much more likely to pick up on a subject if you have a cross type AF point. That's why manufacturers are keen to add more and more, because AF performance is kind of sort of increased by sort of 100%. The other big thing about the AF system is trying to improve the sensitivity of how low light you can shoot in. So sports guys, wildlife guys, they need to shoot in lower light conditions. So in the center, we've now increased the sensitivity down to minus EV2. EV2 as exposure is 8 seconds at 1.4, so it's very dark. Normally the weather conditions are, if you think full moon, not actually the moon itself, but the light from a full moon, that's basically EV minus EV2. Obviously the light towards the edge falls off, as it would with a lens, so the AF performance is slightly dropped compared to the center, but basically it's still 1.5 stops better than the Mark IV. Also the processor in the 1DX for AF by itself, the special AF processor, is 4 times powerful than the Mark IV. So we have a special sensor metering chip for the metering, special processor for the AF as well. So basically now we have these cross types, we have a lot more. We have cross type for all our L series lenses. Before, one of the big issues was we only had cross type with 2.8 lenses and a very few f4. After that, you would basically, difference in AF performance between the 1D Mark IV and maybe your EOS 600D was very small. But now, you have greater AF performance with a greater range of lenses. So at 2.8, you have your 61 with dual cross type. At f4, you still have your 61, but you've lost your dual cross type. And at 5.6, you have your 21 in the center. So, much greater capability. Getting wildlife guys shooting with 800mm, you've got a lot more choice of places where you can focus from. Previously, you had one AF point. However, there will be some differences depending on the lenses, and that's more to do with the optical design of the lenses than the actual aperture. There is some lenses will kind of have a small image circle, which will cause certain AF points not to become active. You will see those in the viewfinder. The camera will tell you in real time, and there's a whole chapter in the manual telling you which lenses work with which AF points. So the AF system is not just the sensor and the chip. There's a whole sort of ecosystem. We have things like the customization. You have your AI servo, your single servo, your face detection. You have a light source detection. So basically, how the camera detects focus and light depends on different light sources. So daylight versus fluorescent light, you get a very different frequency of light. And the camera needs to know this when it makes exposure sort of focusing. Also, with the 1DX, we will now be able to upgrade the firmware in lenses when you connect it, so improving AF performance. Also, what's interesting is the now uses a gyroscope in the camera. So if you're panning, previously the camera knew something was moving. It didn't know it was the subject, or it didn't know it was you. So it may try to change the AF point as you move pan with the subject. So it may end up focusing on something else. Now, as soon as the camera detects a movement, it knows you're panning and stays on the same AF point because it hopes that you'll carry on tracking the same subject. So it's not going to kind of move the AF points jumping around, etc. So as I mentioned before, we now have the new ITR system, which is using the metering system. So it looks at the scene, detects faces. If it can't detect the face, it will go to colour. If it can't detect any real big colour differences, then it will go to conventional AF system. So it has this big loop. So you can turn it on and off. Why you want to turn it off? Maybe if you're doing architecture of a building and people walking through, it's going to lock onto the faces and start tracking them instead. So that's why you can turn it on and off. For moving objects, sports, weddings even, or wildlife, it's probably great to turn it on. It's going to help AF tracking greatly. So this is the face, as I mentioned before, face detection has been around for a while in sort of consumer cameras. You can pick up a kind of a power shot or an Nixus, you can actually see it working. But this is the first camera that does it in real time through the viewfinder, so it's actually doing it with a conventional AF system for speed. Phase detection is still the fastest AF system available. Very, very fast, very sort of easy to use. And this combines the best of both worlds, so it's picking up faces and tracking them around at the same time. One of the other changes that's quite nice, that users will kind of come to appreciate, is the AF menu has changed dramatically. We have now put all the AF functions in one place. Previously, it was almost as if Canon randomly scattered AF functions throughout the menus and not had thought about it. The AF functions had developed over a period of time from the EOS 1 and they appeared. I think one of the greatest examples is custom function 4 on the Mark IV only worked if you turn custom function 8 on, which isn't very logical to think about it. Yeah, you have to go to custom function 8 to come all the way back to custom function 4. So the designers thought, right, let's put all the AF functions in one area. And then we group them into groups that are related to each other. So if you're changing AF functions, it's much more logical when you find things that are related in the same menu. So you don't have to go from different places to kind of set up your AF point. It's all in one place. Obviously, one of the greatest features of the 1DX, that's going to be a big improvement for wildlife, etc., is the AF configuration tool. Basically, AF has got to a certain point where it's very accurate, but to get to that next stage, customers need to understand how it works and fine-tune it for their type of photography. For example, ice hockey versus field hockey. Basically, fundamentally, it's a very similar sport, but as you know, it's very, very different. Speed is obviously greater in ice hockey. The actual kind of size of the pitch is very different. How fast subjects move in and out are very, very different. So you need different settings. You can't do the same type of sport with the same settings. You know, photographing 100 meters racing versus sort of football, very, very different. So now it's up to the customer to kind of help fine-tune the camera to move it forward. And Canon in the past maybe just kind of let the customer fend for themselves and hope they read the manual. Now we've invented this AF configuration tool which has certain presets which helps guide you in the right direction, gives you the first step of setting the right settings for the type of photography you're doing, and then you can fine-tune it yourself if you need to with help files. So if you pick up the camera, you'll notice there are, in the AF menu, there are 6 kind of presets. They're called cases 1 to 6. All the text is translated into different languages. There's a help file you can press, you can scroll through. It tells you what's going on, how it works, what way to change the settings to make it improved, etc. And you can also go in and fine-tune it if you want to as well. You can authorize the settings, but it gives you a base setting of where to go. For example, if you use something like the football icon there's a little guy dribbling with a football. This is going to be ideal for motorsport or for football. Previously with AF systems, they kind of predicted that the subject was going to be moving in a straight line. They measured the distance and then worked out, like, this subject is moving at this speed and it's going to carry on going this way. Where it all went wrong is when the subject stopped. Imagine you're dribbling with the ball and someone tries to tackle you. You're either going to fall over or maybe stop or going in a different direction. The AF doesn't know this. And there you kind of got an image where it was out of focus, where the camera had to rethink what it was doing. Or motorsport. If you think of a car coming towards a corner, or a motorbike, it's going very fast, it slows down, changes speed, changes direction, and speeds up again. With this kind of new function, the acceleration and deceleration control, you're telling the camera that's what's going to happen, and look out for these changes. And if it does detect a change, get ready to change how you're predicting the subject's going to go, and create a whole new prediction. Because that's what these AF systems work on, is prediction, just guessing, best guess possible. By adding, tweaking these settings, you're improving its guess rate to give you a better AF performance. Other little changes, go back to one, sorry. Previously we had this function in the Mark IV and the 7D, the AF tracking. However, the wording was kind of complicated because we used the word fast and slow. And as everyone knows, fast is better, right? However, depending on the type of subject you're shooting at, it was worse. So what we experienced when we first introduced it is people tend to get worse performance because everyone doubted the fast. The trouble is fast is it means it will readjust AF very, very quickly. As soon as the subject moves, it tries to find a new AF point. The classic scenario being the breaststroke. So there's someone swimming towards you, and they'll kind of go underwater and then come up. So there's something in your AF point, then disappears, then reappears, then disappears. What's the camera meant to do? With fast, it would try to find a new focusing point straight away. If you dialed it down to slow, it would kind of keep on its prediction and wait for the subject to reappear. And it's a misunderstanding of how these functions work, caused some issues. And now we've changed it to kind of locked on or responsive to make it a bit easier to understand what it's doing. I think I'll explain this one, so we can skip this slide. Also new is the micro adjustment. Micro adjustment has been around for a while. It's always nice to have micro adjustment straight out of the box, perfect, but not everything is perfect in the world, as we know. So now we've helped micro adjustment slightly better. Now you can, for zooms, you can set a wide point and a tele point. Previously you had to find a happy medium for zooms that worked for both settings. Now you've got one for each. You can also adjust it by serial number. So if you've got the same lens, or if a friend's got the same lens, and you want to swap lenses, basically it will only apply the micro adjustment to the serial number it recognises. The lens is a bit older, you can manually input the serial number, so it memorises up to 20 different lenses. So as you swap them around, you don't have to worry about having the wrong micro adjustment. You'll always have to remember which micro adjustment for that lens. So the body, the whole thing with the 1 series is we try to keep it consistent. So anyone who's ever used the EOS 1 film camera will pick up the 1DX and find it very easy to use. Our buttons haven't changed too much, but we have evolved it slightly. So obviously one of the big obvious things is the 2 new buttons on the front. In the past, cameras always seem to be designed for shooting sort of in the landscape orientation. But as we all know, we take an awful lot of photographs in the sort of vertical portrait orientation. But the camera wasn't really designed to work that way. You lost all your controls, it's very fiddly to shoot in that direction. We're now, with the 1DX, trying to make it as easy to shoot vertically as it is horizontally. So we have lots of buttons which are duplicated, one for vertical, one for horizontal shooting. On the front here we have 2 depth of field buttons and a custom function button that will work in either orientation. So there's sort of the 2 cameras, the 1D Mark IV and the 1DX. Again, they look very similar, but there are subtle changes. We've now kind of made the ISO button slightly easier to find with gloves, etc. Also, there's now a dedicated white balance button on top as well. White balance is obviously being used a lot more, which frees up other buttons on the back. The back has changed a lot as well. Obviously, one of the obvious things is the screen is now a 3:2 ratio. So it's slightly bigger, but it's more sort of longer than it is high. Because most of the still photographs you take are also 3:2 ratio. So when you looked at them on a 4:3 screen, you had a nice black bar at the bottom, so the picture was quite small. Now, this picture can fill up the whole screen, and you get a much better, clearer view. The resolution has also increased. As you can see here, the buttons on the back have also been duplicated for horizontal and vertical shooting. So there's a little comparison between the two. Again, Obviously not too dissimilar. Anyone who's used a 1D Mark IV should be easily pick up the 1DX and be able to shoot it almost straight out of the box. Another change was the introduction of dual compact flash cards. Obviously one of the big complaints from some photographers was, why do I have to have two types of memory card? You know, why do I have to buy two? It'd be great to, too far. It'd be great just to have one memory card. And compact flash cards with many pros, they prefer them because they're bigger and less easy to lose. Also, compact flash cards are now much faster and much greater capacity than SD cards. In the early days when we introduced it with the 1D series, SD cards seemed to have the greatest potential, but now compact flash cards are moving forward. One of the other things we've added to this camera is the new UDMA 7 standard, which is literally just starting to creep into memory cards now. I think SanDisk do their ridiculously expensive 128 gigabyte card, is currently the only UDMA 7, but it's where the cards are going. It has a write speed of 167 megabytes per second, so it's stupidly fast. The camera also supports something called exFAT. Memory cards in the past were based on a very old Windows standard called FAT32. And anyone who use old cameras know that you can only shoot a 4 gigabyte movie of 12 minutes. That's because of this FAT32 limitation, where you only have a file of 4 gigabytes, which was fine if you were doing Word files or Excel. You would never need an image that was like sort of more than 4 gig. But when we got to movies, that was a big limitation. exFAT is a new kind of memory card format that's going forward, which allows a file up to about 1 terabyte, which is a hell of an Excel file, but it also allows us to record bigger movies without stopping. This is, up to now, it's not been sort of really publicized because Macs didn't support it, but from Mac 10.6.5, I believe, Macs now support it. So it's kind of more available to all users. So again, you need to format the card on your computer before you use it in the camera to get this functionality. Just as with the Mark IV, you can either shoot with 2 cards, you can either have them auto switch, so once one card fills up, it starts right into the next card. Or you can record separately, so you can record JPEG to one, RAW to the other. Or you can record multiple, so it records both files to both cards, so you almost have a backup. So you can record RAW and JPEG to 2 different cards, and they're kind of safe. A subtle change we've also done is we've updated the UI. It's the biggest change we've done for a while. Because the screens got bigger, etc., we've now had more characters, so we can try to make the menus a bit more easy to understand. Previously, some of the functions were developed without us understanding. The Japanese engineers explained how they worked, and we had to kind of figure out what they meant. And often later on, you would discover the explanation wasn't quite right. So we often had some names as a legacy that really didn't describe what the function did. So we've gone back and we've renamed some functions to make it easy to understand. There was at least one function that I would understand for a while, forget, then have to get the manual out, go, and then promptly forget again, because the UI string made no sense. Now we understand what it does, we've gone back and renamed it. So those with previous cameras may find some of it confusing to start off with, but it becomes much, much clearer. Again, all translated. We've got the pro guys, the guys who actually use the camera to translate the UI strings this time. One of the things you will notice when you pick up the camera, anyone who's used a Mark IV or 5D or any of the sort of previous kind of pro cameras, is you used to use the 2 kind of AE and the AF button to A lock to zoom in, zoom out. We've now got a dedicated Playback Zoom button, which to start off with may not be the most easy to use, but once you find this function here in the play menu, you can actually customize how quickly it zooms in. Instead of just going like 3 stabs to get in and then to get out again, you can single press, go to the exact magnification you want, and then out again. So you can either set these magnifications. Actual size gives you 100%. So it's exactly 100% for the screen, so exactly how you may view it on your computer. The bottom one, which is marked the same as the last magnification, is you preset a magnification, and when you press the magnification, it goes to that same magnification every time. So this is kind of a great kind of tool, kind of customizing how you play back. And once you set this function up, it becomes much, much quicker. It's a simple button, in and out. connectors on the side, we've obviously got the same sort of connectors we've had previously, but the new sort of connector really is the Ethernet. Some people think, why would I need Ethernet? Basically, Ethernet is sort of a great kind of functionality. It supports gigabit. Practically every computer on the planet already has an Ethernet port built in. So you're already up and running. You can run cables up to 100 meters. They're very cheap. 100-meter cable will cost, in euros, about 40 euros. You know, they're very, very cheap for 100 meters. Yeah. USB struggles beyond 10. And Ethernet, if you do want to go more than 100 meters, you can then put a router in between and then run another 100 meters. So you can control from great distances. It also has a very fast gigabit of 125 megabytes per second. So faster than USB 2. Maybe not quite as fast as Thunderbolt, but there aren't many Thunderbolt computers out there at the moment. And anything that you can do with EOS Utility via USB, you can do via Ethernet as well. So studio work, it's great. Also, the best thing about Ethernet is it doesn't pull out easily. It has those little spring clips, basically, that can kind of lock it in. And when you do break the connection, Ethernet allows you to connect really quickly. USB takes about 30 seconds. Ethernet will reconnect it within 5. So if it does pull out, very easy to pump back in, and then it will reconnect instantaneously. So earlier this year, we introduced the Coolpix S100 and the SX40, which introduced Digic 5 processing. For the 1DX, that wasn't powerful enough, so we introduced our more powerful processor, the Digic 5 Plus, which is 3 times more powerful than Digic 5. It has a greater front bandwidth, so more data can go through into it faster and quicker. It's also 17 times faster than Digic 4. And this camera has 2 of them. So this allows us to shoot 18 megapixels at 12 frames a second. It allows us to turn on all the kind of functions that normally slow down the camera, because it can be all done in the processor. Previously, other cameras used to use the buffer to kind of eat up some of the space. But now it's much, much faster because it's all done in processing. So the ISO range. So the sensors allows us to get the ISO range and the digital processor. So the default range is 100 to 5100, 200. So we can expand that if we want to. Canon has a strict kind of guidelines. These are our kind of these are settings we're happy with the quality of. But there are settings that beyond that which are available, which will see a drop in performance. And by activating them, it's almost like a sort of acceptance that you accept that there will be a drop in quality and you're happy to use them. That's why they're not available as default. So we have a 50, which is kind of, again, kind of unique to Canons for sort of bright conditions where you want to use slow shutter speeds. We have 102,400 and 204,800. Yeah, the picture quality may not be great, but if you need the shot, it'd be great for about A4, some newspaper stuff. If you need to shoot, then it's going to be handy. But don't expect to be able to do massive prints of super high quality with this, unless you want it to look like a kind of an impressionist painting, really. So with movie mode, we've reduced the ISO. We keep it down to about 25,600. Because movies, because it's moving, any noise is random. And then the random noise start to flicker as it moves around. So it becomes much more distracting noise on a movie than there's on a still. On a still, you have noise, it doesn't move. Noise in a movie will move around and it becomes very distracting. So we've limited the ISO on movies to prevent that kind of random noise flicking around. So it's less obvious. So obviously high ISO, low noise. We've improved the sensor technology, so we've got much bigger pixels than before. We've improved how efficiently it converts the data. We also have the Digic 5 processing, which reduces noise. So currently we're happy to say it's about 2 stops better than the Mark IV. So 5,100, 200 is equivalent to 12,800 on the 1D Mark IV. Hopefully this might give you some impression. So this is a 12,800 image shot in a band, so it's very low dark conditions. As you can see, maybe here, there's not that much chroma noise. There's 2 types of noise, there's chroma noise and color noise. Chroma noise, which is color noise, and luminous noise. Let's just see if it zooms in. So this is a bit more closer. You can see there's no color speckles. That chroma noise that you have, those big kind of splotches of like red and green and blue that kind of flick across, that really horrible kind of thing to get rid of and very difficult without sucking the color out. As you can see, we've got beautiful reds, beautiful yellows, none of that color chroma noise. You might see a bit of luminous noise, which is quite nice. Anyone who's used film, black and white films, always like that kind of gritty, grainy feel. and luminous noise kind of gives you that kind of same effect. So luminous noise is very easy to remove in software, but chroma noise is very difficult. But the Digital 5 does allow us to really kind of reduce it in camera. And you can see here, there's very few chroma noise. This is an image that was shot last weekend, just to show you again. The lighting isn't great. There was no famous Swedish racing drivers I could find, so I found the next best thing. So here again, it's not too bad. I'm quite happy with this on the screen. But it's shot at 10,000 ISO on a sort of prototype camera, and it's literally a crop of that. They actually used this image sort of in a sort of magazine, sort of already at this sort of setting. They're quite happy to use that kind of quality. And that's just a crop of that at 10,000 ISO. That was also shot with a 400mm with a 2x converter at a press conference at the Abu Dhabi Grand Prix. Also, for the first time on a Canon camera, we have multiple exposures. We can shoot up to 9 images, combine them in the camera. There are 2 ways of creating multiple exposures. You can do continuous shooting or montage. So you can do almost like someone throwing a dart, or that classic kind of ski jumping or motorbike, etc. So flying through the air. But you can do a montage where you can kind of create different images. You can shoot, I think the classic cheesy example is you shoot the moon with a telephoto lens, then you shoot the cityscape and you can kind of put the 2 together. That kind of stuff. You've got the 2 options really. But there are also 4 different ways of how you combine these images. We have an average addition, which is kind of very similar to conventional film multiple exposure. We have an average, which will, you can take 9 exposures and the camera adjusts the exposure for you to combine the images. You have bright, where basically only overlays the brightest parts of an image, and dark, which will only overlay the dark parts of the image. So the dark is kind of useful for if you have spectral highlights, like reflections on the subject that are moving around. Basically, the dark will remove those reflections because they're brighter than the other exposures. So we'll kind of get some more images out and do some more, kind of show you how these work near the sort of launch time. So the mechanics of the camera, again, obviously we've improved many things, but obviously 2 of the big things is the shutter. Shutter life has now been improved by 25%. So there's a 400,000 cycle sort of shutter. Basically, the shutter is much more reliable. Basically, we're looking to prove the guarantee that. So basically, if it does go wrong, you get a free shutter repair as long as it's below 400,000 cycles. Also, because of the new mirror mechanism and the shutter, we can do 12 frames a second. So probably the fastest kind of mirror activator system ever. You get all your controls. You can shoot in RAW. You can control the exposure. All that's possible with this sort of camera. Also, it has the shortest shutter lag of down to 36 milliseconds. Previous cameras on the Canon cameras, you could do is about 55. Depends on the lens that you use. So, but the difference between 55 milliseconds and 36 milliseconds sounds very short, but if you're photographing a motorbike and a motorbike GP, in those milliseconds, a bike can travel 5 meters. So being able to shoot faster allows you to get the bike where you want it in the frame without having to wait. Obviously, the other new function is the 14 frames a second, which is the fastest on a production camera. Previously, the only camera that shot this fast as a still camera was the Canon F1N high speed, back from the sort of mid-80s, which shot 14 frames a second film, but was obviously very limited and was very expensive and made a very limited run. But we can now feed the data out at 16 frames a second, from 16 channels, and get 14 frames a second. Basically, how it's assigned, you can either assign it to a custom function button, so activate it instantaneously, or activate it via the drive mode. It's going to be ideal for static sports, really, because the AF is locked on the first frame, and so is exposure. So it's baseball, for example, is a scenario, or the golf swing might be another great scenario, where the subject is moving a lot, but there's a lot of action in that frame at the same time. We've also improved the sensor cleaning system. Previously, the sensor cleaning system dated back to the 400D. Basically, it literally just flicked the sensor and hoped that the dust kind of fell off and dropped in an appropriate place. But unfortunately, what we discovered over a period of time, especially the larger sensors, that the dust sticks to the sensor that you can't get rid of, and the bigger the sensor, it becomes more apparent than on the smaller sensors. So we needed to improve how we kind of clean the sensor off the dust. So hopefully this little analogy or graphic might work. So the old system here, basically the sensor just flicked, the dust was flicked off, some of it came off, some of it didn't. With the new system we're using a wave, so basically using the same technology we use in our lenses, we're now trying to make the dust travel down the actual sensor into the sticky tape area at the bottom of the camera. So it basically kind of forces the wave down, so it's actually pushing the dust in a different direction. Previously it was just a kind of a flick, so the dust went out, it could maybe attract it back, and now it's forcing it onto the sticky tape. So another nice little feature for some users is we now have a system display. This shows you the serial number. Some guys using cameras may notice the serial number rubs off after a period of time. It's now locked into the system, so you can see it on the back of the camera. You can also see the number of shutter activations as well. So you can actually see how often the camera's been used. It's rounded down to about 1,000 because sometimes in the first few, the cameras are tested as they come to the factory, these cameras. So these cameras will never have a 0 shutter count because they have to be tested to guarantee them. The same as your car, when you buy a car, it never has 0 mileage on it. It always has to get from A to B. So this has a sort of a shutter count. Also, we'll actually log all the error messages that you have in the camera. Previously, some cameras will flash up error 99 and then disappear, never to be seen again, this error message. Now this error is now logged into the camera. So when you take to see someone to be repaired, and the camera magically works for them, but not for you, they can actually see when it went wrong, how it went wrong, what settings we're using. So basically, also the camera will actually, if it gets the same error a lot, the camera memorizes this and tells you, look, there's a problem with the shutter, maybe it's time to go see the service guys. So the camera's telling you what's going on, you can see faults, and you know when it's time to get the camera serviced. In the past, it was kind of, only went to see the service when they stopped taking photographs. The camera's now actually warning you in advance before you go on an important shoot that it may be a problem. So movies. Now, the sensor has been redesigned. It now, previous to the 5D, it scanned every other line and fed them out. That's why you kind of got this jaggedy banding, so not every line was used. Now it looks at the whole image, so you get the whole wide angle, and it's processed on the chip and downsized. So you get less artifacts, less jaggy, less moire, and sort of better picture. So again, let's see how this looks here. You can see here on the old one, you can see the kind of patterns kind of appearing much more. On the new one, you've still got a few, but it's greatly reduced. And when you move around, you notice them a lot less. Maybe this picture might show you a bit better. You can see the horrible striking pattern on the one on the sort of your left, but on the one the X on the right, that sort of horrible pattern as you move around will disappear. So it's a much cleaner sort of video signal. Obviously, one of the other problems we had with the previous cameras, as I mentioned before, is down to the FAT32, we could only record 4 gigabytes and then the movie stopped. So that worked out roughly 12 minutes of video. Now the camera will automatically generate a new file once it reaches that limit. So you can carry on filming non-stop. Basically, you'll get no drop frames, but each 4 gig will be a separate file. You just need to edit them together later on. To help you do that, there's also time code. So each video file has a time code. That means it's easy to match together on the video line. It also allows you to match multiple cameras together using the timeline, using the time code. So another nice feature is you can also assign movie start and stop to the shutter button. Previously you had to press like the set button or the FEL button, etc. However, if you started using a rig or kind of wanted the camera remotely, it was very difficult. By assigning it to the shutter button, it means we can now use all our remote controls. So use the wireless remote control or cable remote control. You can stop and start the movies wirelessly or cable. So if you've got a rig like this, you can now kind of take a cheap wireless remote here and stop and start the movies very, very easily. Before, it was holding it here and then having to reach around, which wasn't the most easiest way to do things. Obviously, one of the big requests was audio recording, audio levels, etc. during movie recording. Now we introduced manual recording with the 5D Mark II, but now we're taking the next step. You can now access it on the screen by pressing the quick control screen. You can actually adjust it brings it up. You can dial it up and down. One of the other features we've added for movie users is inside the actual back control wheel is a touch sensitive area. If you press left and right, it will alter the sound levels up and down. So instead of having to click a wheel, which affects the noise, you can go up and down. And in the final firmware, you'll be able to go up and press up and down. It will change the aperture. So again, no clicking of the wheel when you change exposure, no clicking of the wheel when you're altering the sound. You can do it all silently by just touching the back of the command dial. So the other features in the movies was we now added a new compression option, which is all I versus IPB. Both are basically H.264. They are both already included in the H.246 standard, so there's no extra software needed. So if you're using Final Cut Pro or Adobe, this will work straight away in the software. There's no special software needed. All I basically records each frame as a separate frame, so it's easy for editing. File size is 3 times larger, but when you drop it into the software, basically it will play almost instantaneously without having to render, because you have every frame there. The other system, IPB, records only one keyframe, so it records, you record at 24 frames a second, it records one still image, and then it has to record compressed versions of the other 23. And when you put it on your computer, it then has to regenerate those missing 23 frames to full frames. That's why it was so slow and jerky and why you have to render stuff. You did get much, much smaller file size, but it basically meant that all the hard work had to be done by the computer later on. All I should take that away, you get less compression, but a much larger file size. So the EOS system, the 1D Mark IV will fit into the EOS system quite nicely. It will use the exact same power adapters as the 1D Mark III and the 1D Mark IV. The new battery is slightly larger capacity, a few extra kind of things, but the batteries are backwards and forwards compatible with the slight provision of the battery charger will not charge the old battery charger will not charge the new battery charger to 100%. It will charge it to 90% because the new battery has a slightly larger capacity. And we can't really kind of update the charger, but the new charger will work with all batteries and vice versa. There's obviously a new GPS device that will clip on. It's kind of tiny kind of thing. It's probably the size, half my size of my thumb. Clips on the side, records GPS data, longitude, latitude, altitude, and has a digital compass, so it knows exactly which direction you're pointing in when you took the photograph. And obviously we have a new Wi-Fi transmitter, if you don't want to use a LAN, that will fit on. That has a built-in Bluetooth transmitter as well, so you can connect it to other devices. If you don't want to use this GPS, you want to use a separate GPS, or you want to use things like barcode scanners, etc. So that can be connected onto the side. But most of the accessories, the eye finders, etc., are all the same as our previous cameras. So I'm coming towards the end of my speech. Any questions? Okay. That's me done.